such that this division implies that the function is equal to this times the quotient plus the remainder, right? And so what we got at sort of the end of this process, this is the remainder, right? We had all that in there. So this polynomial divided by this polynomial is going to give us this polynomial, but with a remainder of 3x plus 5. What is that symbol? So again, in the homework, when it says, you know, here's a polynomial, here's another one, find the remainder, this is the process that you should do. You should divide them out almost exactly as if they were numbers, with the different terms being different digit places. But we just have to remember negative signs wherever they crop up, because you are always subtracting the product from the thing that was left. All right, let's do one more example, and then we'll move on to the rational root test. So let's do another big polynomial. Let's do 2x to the 5th plus 5x squared minus 10x plus 1. So this one is degree 5 because it has x to the 5th in it, and that's the largest one. And it's missing both x to the 4th and x to the 3rd terms, but that's fine. It's still a polynomial. And we're going to divide this by, let's say, x cubed minus 2x squared plus 1. So now here's the first time that we are doing this where it isn't just some x thing and some constant. Here we have two different x terms that we are dividing by. And so this is going to make it a little bit more complicated. So let's do it out. We have 2x to the 5th plus 5x squared minus 10x plus 1. And we're going to divide by the entire quantity, x cubed minus 2x squared plus 1. And we ask the question, what is the nearest multiple, yada yada. I'm not going to go through that every time, so I'm just going to say, in order to turn this x cubed into an x to the 5th, I need to have an x squared, so that when they multiply, the exponents sum and we get a 5. I also know that we have to get a 2, and since this doesn't have anything in the front, I have to put a 2. And when we distribute this in, we're going to get 2x to the 5th, and then 2x squared times negative 2x squared is going to be negative 4x to the 4th, and then negative 2x squared times plus 1 is just plus 2x squared. And we subtract off this entire thing. The first terms cancel, and since we don't have any x to the 4th terms in the thing that we are dividing, there's nothing we can do to cancel anything. So this is going to be minus 4x to the 4th, which is going to be plus 4x to the 4th. And then we do have a cancellation here, because we have 5x squared minus 2x squared, which is going to be 3x squared. Now, since this is a 3-term thing, we're always going to get a 3-term thing down here, so I'm going to have to pull down the next one, which is negative 10x. And now we ask the same question, what do I have to multiply this by so that the leading term cancels this? Well, I need to turn the x cubed into an x to the 4th, so I need an x, and I need to turn this 1 coefficient into a 4, so I need a 4. And since it's positive, it's going to be positive. Now we distribute this in, we get 4x to the 4th as we intended, and then 4x times negative 2x squared is going to be negative 8x cubed, because 4x times negative 2x squared, again, it's going to bump up the degree by 1. Lastly, 4x times plus 1 is just 4x, and now we subtract off this whole thing. First terms cancel as intended. There is no cubic term, so this thing just comes down. It's negative negative, so we get 8x cubed. There's no squared term down here, so there's nothing to cancel with this, so we still get 3x squared. And then we have negative 10x minus 4x. So this is going to be negative 14x. And now we do this one final time, which is to say, what do we need to multiply this by so that the first term cancels with this? Since it's already x cubed, we only need to multiply by 8. distributing the 8 in, we get 8x cubed. 8 times that is negative 16x squared, and plus 8. We now subtract it off one last time. The first terms cancel. The second terms, we're going to have